Hello all. Today we will learn about the navigation in the drone. In this video we're going to focus mainly on the rotation, but in the next video we're going to cover the translation as well. So let's get started. As you know, we have mentioned in the last video that there is a reason for these motors are spinning in the opposite direction, and that way it actually compensates the torque. So it doesn't have any motion along this z axis, which we call the yaw motion. So we use the same principle to induce the yaw. So whenever we want to turn this quadcopter, let's say we want to rotate it around the yaw in the clockwise direction. So at that point, what we do is that we decrease our clockwise motor spinning and we increase our anti-clockwise motor spinning. So this phenomenon at this point cases, since these motors are spinning in a counterclockwise direction, it's gonna induce a clockwise torque on our drone, which is gonna make our drone rotate along the axis in a clockwise direction. Similarly, to achieve the anti-clockwise rotation, we are going to increase our clockwise running motor speed and decrease our we're going to increase our clockwise motor speed and decrease our anti-clockwise motors. This is going to, so we have here a net torque in a clockwise direction. So this has a net clockwise torque here. So this is going to have an effect of anti-clockwise torque on our body, which actually makes our quadcopter to rotate in anti-clockwise direction. So basically this is how we achieve the yaw motion in the quadcopter. And there is a roll along the left and right axis. So the idea of the roll is that, let's say if you want to rotate around the left and right axis on the left side, so you increase your right side motors spinning and decrease this left side motor spinning, which actually cause our quadcopter to rotate like this. The same phenomenon could be used to achieve the opposite effect. You increase the left side motors and decrease the right side motors, which actually cause our quadcopter to rotate in the opposite direction. Similarly, finally, the pitch motion. So pitch is actually an angle with a front and back axis. So to bend towards the front side, what you do is that you're going to increase the backside motor spinning and decrease the front side motor spinning. Automatically it is gonna cause the quadcopter to bend on the front side. To achieve the opposite effect, you increase the front side motor spinning and you decrease the back side motor spinning. So at this point, I can recommend you these videos again. So they have a good graphics on how actually the drone flies, and you can see these motions with the graphics in a 3D mode view, which can help you understand as well. Hello all, welcome to the practical session now. So we are going to do the testing with our rotation motion in our quadcopter. So I have the script here. So we're going to use the same script which we have used previously, but we are going to do some modifications where we are going to implement this rotation motion. There are actually two different functions which we can use to achieve the rotation motion. One is like a rotational or angular displacement, where you just give certain angle. Let's say I want to have rotate the drone around 50 degrees, so you just give that distance, and it's going to, you just give that angle, so it's going to give it to that position, so which is actually this one. Here you could see that it's actually moving by roll, pitch, and yaw. So let's first check with the yaw, and after that we will go to the other two angles. So let's try to rotate our drone along the yaw up to 50 degrees in degrees. So here the function you can see, like it's, this one is roll, this is pitch, and this is yaw. And this jet distance is actually the desired jet distance which we want the drone to be after the goal location. Because when we have this angular displacement, sometimes the altitudes may vary. So we wanted to have a certain altitude. We don't want the drone to crash. And you could also see that AirSim uses net coordinate system. That is the reason why the negative number means you're actually having an altitude of certain height. If you give positive, which means you're going to the ground. So it's a net coordinate system, so be aware of that. And this too here is a time, so the time which we're giving until which time it should reach the desired location which we want. So think of it as a deadline time, and of course our vehicle name. So by the end of this script, we can see that our drone will rotate around the yaw up to 50 degrees. So let's go ahead and execute it. So you can see that the drone is actually now tilted along the z-axis by a certain angle, the 50 degrees. So we'll also check actually how actually we see the angular displacements about the other angles. Let's check the pitch axis first. So the roll and pitch actually here in the HM is that I'm gonna show here maybe. So this is actually the front is actually x-axis, and the left and right this is y-axis. So this one is x-axis and this is y. So that's why the pitch is actually make you an angle along this axis, whereas roll is about making an angle on this side. So I'm going to give some angle here. Don't give a big angle for the roll and pitch, otherwise you can see the drone is going to crash. So we don't want to give it some 50 or 60 which make the drone directly shoot down to the ground. We don't want our drone to crash, we want it to fly. So that's the reason why we'll give very small angles to the roll and pitch. Let's give some 10, maybe 10 degrees. You can see that it performed the roll, pitch angle. And you could also see that when we give the pitch angle here, it has a displacement along the x-axis. Did you see that? Like it actually moved a certain distance, right? So we're actually going to cover why it did like that in the translation motion. And this is actually how we achieve the translation in the UAV, by providing this, by changing these roll pitch angles. We'll cover those detailedly in the next tutorial, but now be aware of that it actually causes the translation motion. Now I'll try to give the same angle to roll, and guess this time which direction the translation can happen. Do you think the translation happen or not? If it is, which direction do you think the translation will occur? So yes, you guessed it correctly. There will be a translation, and it is along the left and right axis. As you can see that it's making some angle with the roll. It actually causing it to translate around along that axis. We'll cover that detail in the next tutorial. So we have seen that how actually we are performing our roll, pitch, and yaw motion here. And we have seen that the roll and pitch are actually contributing towards some translation in the vehicle motion. We'll cover those detail in the next tutorial. So we have checked like providing some roll, pitch, yaw displacements which we want. But sometimes we want it to have a continuous roll angle, continuous pitch angle, continuous yaw, which is like a velocity which we wanted to provide with some velocity. Well, let's say I want my vehicle to rotate at 10 radians per second all the time, right? We want something like that. For that, we have another function which actually mostly we're planning on using. So we might not use much of the time this providing with certain angle where we will provide the velocity. So we provide the angular velocity to achieve the desired orientation. So this is actually the function which we use for that. And I'm not going to give any angular velocities for roll and pitch at this point, because if we give, it might cause our drone to go into instability state. So basically we are going to use mainly this function to achieve the yaw motion only. So let us give let's say 50 radians, and I want it to perform with so here the functionalities is like this. So we are giving angular velocity, roll angular velocity, yaw angular velocity, roll angular velocity, pitch angular velocity, and yaw angular velocity. And this is the desired altitude we want the drone to be. And at the time, so how long I want to execute this velocity for. So that is the time here. And of course our vehicle name. So let's go and execute this script. We can see that maybe we'll try to give 5 seconds. So I want this velocity to be executed for 5 seconds. So you can see that it's continuously rotating around the axis for 5 seconds. So there you can see that the vehicle is continuously rotating around its axis for 5 seconds, and after that it starts performing the descent for the landing. So that's all about for this tutorial covering the roll, pitch, yaw. Next tutorial we're going to learn about how actually drone perform the translation. We have actually seen here today, but we're going to understand the science behind it, and we're actually going to use some functions to achieve to the desired position which we wanted to. And thank you very much for checking the tutorial, and I will see you all in the next video.